I'm Anil Kumar sharing with you a video on factors. Now this topic is of very much interest to students in grade 6, 7 and 8. I would like even parents to watch it so that they can get something out of it in a way that, summer holidays are around the corner. They can help their kids learn much more and effectively during the summer. I'm going to touch upon these topics: factors, products, prime numbers, composite numbers, common factors, greatest common factor, and then we'll make a Venn diagram. Now, the whole idea here is to always leave few things to explore. So, these are related topics which you should explore, right? So, what are perfect numbers? How do we do prime factorization? And how to find number of factors? So, these three topics I'd like you to explore. I'm going to take them up in the next video. Correct? So, let's begin by understanding what are factors and how are they directly related with products. So let me take very simple examples. Let's say if I multiply two numbers, that is, let's say 3 times 2. Now 3 times 2 is 6. So these two numbers which we multiply are called factors. Correct? So when we say factors, we are talking about numbers which when multiplied give you something else. So these two numbers here, they are called factors, and these are factors of 6. Do you see that? And what is 6? 6 will be referred to as product of 3 and 2, and we'll say 6 is product of 3 and 2. Does it make sense? So that is how these two terms, factors and products, are very much related. Correct? Now always you'll find that 1 and number itself is always a factor, right? So that brings us to the topic of prime numbers. So always if you take up any number, then 1 and the number itself is always a factor of that number. Okay, so sometimes I'll write number with capital N. So when I say capital N, so imagine it is a number. Okay, so 1 and number itself is always a factor of that number N, right? So should I say these are prime numbers or not? That is a question for you. Okay, so we'll have a question mark here. Are these prime numbers, right? We'll have a question mark here. Let me first tell you what are prime numbers. Okay, so let me write down what are prime numbers and then we'll talk about it. So we'll write prime numbers have only 2 factors. I should write 2 factors. And which are these factors? These factors are 1 and number itself. Does it make sense? So prime numbers have only 2 factors, and these factors are 1 and number itself, that N, right? Now my question is, if 1 and number itself, we know 1 and number itself is always a factor of any number. So if we have number itself as a factor of any number, then are those numbers prime numbers? That's a question to think about. Prime numbers have only 2 factors. The key here is that they have only only 2 factors. So to this rule, we have one exception. Let me write down. This is very important. The number 1. See, 1 has only one factor. Which is number 1. Do you see that? So it is not a prime number. So it is not a prime number. Do you get my idea, right? So it is not a prime number. So what I was trying to say here is that all prime numbers have 2 factors, just 2 factors, one a number itself. However, there is one number which has only one factor, 1 and 1. The number itself is 1, correct? So that is not called prime numbers, right? So now you know what are composite numbers. Can you guess? So composite numbers have more than 2 factors. So I have no space here to write, but let me write composite numbers more than 2 factors, correct? So let me write here. Composite numbers have more than 2 factors. Okay, so I filled up all this space. So what you learned here is when you multiply 2 numbers, you get the product. Those 2 numbers are the factors. So that is how product and factor is related. Prime numbers have only 2 factors. I should say exactly 2. That would be better, right? So prime numbers have only 2, or we could say exactly 2 factors. 1 is not a prime number, right? So all numbers which are not prime and not 1 are composite numbers. Composite numbers have more than 2 factors, correct? Now, once we understand what are factors and all this, let us really work with few numbers, find all possible factors, right? So let's see how to do it. So now we'll explore easy way to write all factors. So let me take very simple numbers to begin with. I'm taking the number 6 itself. So as I said, 1 and number itself. So 1 and 6 is a factor of 6, correct? 1 times 6 is 6. And you also found that 2 times 3 is also 6, correct? So we get one number, 6, and it has 1, 2, 3, 4 factors. Perfect. Now let's take another number and let's let this number be 8. So factors of 8, when you begin with, write 1 and the number itself. Number itself, let me write 8 here. I expect more factors. Let us see. 8 is even numbers, so 2 is also a factor. Now you have to say 2 times what is 8? So that other number will be factor, right? You have to multiply 2 to get the product. So you see the relation now? So 2 times 4 is 8. Is there any other number which can be multiplied to get 8? No, I don't think so. So that is it, right? So we have 8 which has only 4 factors as shown here. So let's take another slightly bigger number, 11. Now 11, as you know, is just 1 times 11. It has only 2 factors. Since it has 2 factors, we'll call this number as a prime number. Okay, so we'll call this as a prime number. And now let me take a bigger number like 30. And let's find factors of 30. Okay, now when you increase the numbers like that, I think I need more space. I'll write 1 times 30. Let me go here. 1 times 30 is 30. So what I'm trying to do here, kind of relating these numbers, right? So I'm connecting them with some rainbow kind of a structure. Now we know 30 is also even number. So 2 times half of 30 is 15. It works, correct? So 2 times 15 is 30. So that becomes another set of factors. 3 times 10 is 30. So we could also write 3 times 10 and connect these two also. So it kind of helps us. In half the time we can get all the factors. Can you divide this by 4? No, 4 times 8 is 32, times 7 is 28. This reminds me, you should know all your tables, okay? But yes, we could divide this by 5. 5 times 6 is 30, right? So 5 times 6 is 30, and then it is 6 times 5, 10 times 3, and so on. So we have listed all the factors of the number 30. Do you see that? Right. So we got all the factors of number 30. Now this is a very easy way of finding factors. Start with 1 and number itself and then converge, right? See, if they are even numbers, try 2. If their sum is divisible by 3, then 3 is a factor. If sum is divisible by 9, 9 is a factor, correct? You should learn the division rules. So I'll say here, learn rules for divisibility. Okay, so there are rules for divisibility which will help you find factors very easily, right? So learn rules for divisibility. That could be another topic to explore, correct? So as I was saying, if you add and if that number is divisible by 3, then the whole number can be divided by 3. Okay, so anyway, so you have learned a very effective way of finding all the factors of the number 30. Now here I will tell you to explore something else also. So let us explore something. That is to say, well, leave out the number itself, 8, that number, leave this number itself. But what you do here is find sum of all factors excluding number. Itself. What do you notice? Let's write down. What do you notice? Right. So take a minute to do that. Perfect. So what I'm trying to say here is for the number 6, add what is 1 plus 2 plus 3 equal to. For the number 8, add what is 1 plus 2 plus 4 equal to. For the number 11, add 1 plus 11 equals to. And for number 30, add all these numbers. 1 plus 2 plus 3 plus 5 plus 6 plus 10 plus 15 equal to, right? Now, these additions will give you some interesting results. And from these results, we come up with 3 more terms, right? We come up with 3 more terms which will be of your interest. And these terms are abundant, one term, right? The second term is deficient. And the third term is perfect. See how these terms could relate to their sum, right? So when I add 1, 2, 3, I get the number 6 itself. Do you see? So we call this as a perfect kind of a number where the sum of factors, not including the number itself, is same, right? The second one here is 3 plus 4 is 7, which is less than 8, right? So it will be called deficient, right? So it is slightly less, right? And 11 plus 1 is 12. So what you notice here is what you get is higher than the number, right? So you could call this as abundant, right? So you could call this as abundant. So number itself, okay, I shouldn't say that. I'm sorry. We do not have to add the number itself. Sorry. So it is just 1, right? It is just 1. So this will be called deficient, right? So it will get into the category of deficient, this category. So all prime numbers will land up in deficient, all prime numbers. Perfect. Abundant is here when you add all these numbers, we get something which is greater than 30, right? So when it is greater than 30, the sum of all these numbers will classify that as abundant. Is that okay? So that is another way you could explore the numbers. So I hope that makes some sense, right? Now, before we take up the next topic, here is a question for you to do. You have to find all factors of, let's take few numbers. Let us say 36 could be one number, 24 could be another number, 80 could be other, right? So try these three numbers, find all factors of these three numbers, and also classify them as abundant, deficient, or perfect. Let me add a prime number here, right? So 89. Okay. Now with the concepts learned, I would like you to explore some of the factors and classify the numbers as abundant, deficient, and perfect, right? So that is the exercise for you. You can now pause the video, copy these numbers, write all the factors of these numbers, add them up, right? Add them up and then see whether they could be classified as abundant, deficient, or perfect, right? Now, let me show you how to do it. So first step is to write all the factors of the given number. 6 could be written as 1 times 6 and also 2 times 3. So 1, 2, 3 and 6 are factors of 6. 18 could be written as 1 times 18. So we know that. Now 18 we could multiply by 2 also, which is 2 times 9. 8 plus 1 is 9. So which can be divided by 9, and 3 also, right? So 3 is also a factor. 3 times 6 is 18. So that gives you all the factors of 18. 25, begin with 1 and 25. 1 and number itself, and then look for in between numbers. In between, what do we get? 5 times 5. That is all. So there is only one number in between. Now we have a number 28. So 1 times 28 is 28. 2 times 14 is 28. 14 is 7 times 2. So we could divide this by 4. 4 times 7 is 28. Now the next number is 7. 7 times 4. So the pattern repeats. So these are the numbers which we have. Now let me add one more number to this list. I want to add a prime number, right? So let's add a prime number, let's say 13, right, in our list. Okay. So if I add prime number 13, I know I have only two factors, 1 and 13 itself. Now we need to explore sum of factors. So we'll do sum of all the factors, correct? That is to say, we are now going to add all these factors. 1 plus 2 plus 3 plus 6 is equal to what? You can calculate using calculator. That'll be simpler, right? So add all these numbers and see what do you get. Now, if you get a number which is twice this number, then it is perfect. So perfect is all factors, or let us do one thing. Let us not add these numbers, right? So it will be the same number. So what we will do is we will add all but not the number itself. So let me mark this as, it will be easier for us, correct? So we'll add only 1 plus 2 plus 3 right down here and compare that number with the original number, right? So sum of factors, let me write here, sum of factors. Factors except number itself. Is that okay? So we'll not include the number, but we'll write sum of all other factors. Does make sense to you? Okay, so let's do it. 1 plus 2 is 3, 3 plus 3 is 6. So we get a number here as 6. Okay, let me write 6 here. Now, if you add these numbers, we get 1 plus 9 is 10, 16, 17, 18, 19, 20, 21. So when you add this, you get 21. Here you get 5 plus 1 as 6. Now in this case, 1 plus 2 is 3, 3 plus 4 is 7, 7 and 7 is 14, 14 is 28. You get exactly the same number. And here, this is a prime number, you'll always get 1 as sum of all other factors than the number itself. Correct? Now in this, you have to compare to classify. Correct? So what do you get? I hope it is very simple, straightforward now. So these two, 6 and 6 match. So this is called perfect. Now here, 18 is less than this. So this is more, right? So here we have more factors sum, right? So we'll call this as abundant. Number 6 is much lesser than 25. So this is deficient. Now in this case, it is exact number. Do you see that? So it is also termed as perfect. Now there are very few perfect numbers, to be very frank with you. What you can do is explore other perfect numbers. I'll have a video on this and provide you a link also. For prime numbers always, sum of other factors will be 1. So this is always going to be deficient, right? Is that clear? So this is the exercise which we have done, and based on this exercise I have a question for you. Question for you is, from here what do you conclude? So about composite numbers. From here what do you conclude about composite numbers? So we can say sum of all factors of a composite number will be greater than twice the number, right? So twice the number. Is this statement true or false? So you have to say, is this statement true or false? Justify. Perfect. So that is the question. Twice the number. I'm not saying sum. Same, right? Sum of all factors. Include that number also. Include that number also. Now the question is, sum of all factors of a composite number will be greater than twice the number. True or false? Perfect. So that's the question for you. Now let's move on and let's take some more questions. And this time we'll see how to find greatest common factor between any two given numbers. We will also extend it to 3 numbers. Perfect. So we'll do between 2 numbers or 3 numbers. So let's take example for numbers like, let's say 12 and 15. So first step to find greatest common factor is, let me list this step 1. So what is step number 1? Step number 1 is you have to list all factors. Correct? So let's list all the factors. For 12, the factors are 1 times 12. Then we have 2 times 6 is 12. 3 times 4 is 12. So I think we got the list, right? So these are all the factors of number 12. Similarly, for 15, we have 1 times 15, and then we have got 3 times 5. Correct. So list all the factors. These are the factors. Now, second step is, let's call step 2, will be circle common factors. Correct. So let's circle. So always one is going to be common. So you don't have to think about it, right? What is something else? Yes, we do have 3 also common. So there are 2 common factors, correct? So we get the answer here is that the common factors between 12 and 15 are, let me write. So we have common factors as 1 and 3. So which is the greatest common factor between 12 and 15? Well, greater of these two, circle that one. That is our step number 3, right? So step 3 is to find circle greatest common factor by comparison, right? Okay, so we get our answer as 3. Does it make sense to you? Correct? So that is how you are going to do this exercise. Now, let me add one more number to this. So let's add a number 18 to our list. Okay, so factors for 18 are 1 and 18, correct? 2 and 9, and also 3 and 6. So these are the factors of 18. Now, if I consider all 3 numbers, so your exercise is to find greatest common factor between 12, 15 and 18. So what will you do? You consider 18 also, right? So circle the numbers which are common to all, right? So what we find here is that these 2 numbers are again common to all. So again, the greatest common factor remains as 3. Is it okay? Perfect. So that is how we actually do it. Now, as an exercise, what you can do is, let me add a question for you. And the question for you is, find greatest common factor between, let me give you 3 numbers this time, 15, 24 and 30, right? So find greatest common factor between 15, 24 and 30. So I hope that helps. Now we'll move on and take up next example based on Venn diagram. So we could actually use Venn diagrams to find greatest common factor. So here are 2 very good questions to work with. You can actually pause the video, copy these questions, try them out, and then check with my answer. You need to draw Venn diagram to find greatest common factors. I hope you remember what Venn diagrams are. It's like making circles. Do you see that? Kind of like this. So you have to make circles, and in between you have to place the values which are common to 2 or more groups, right? So you could make, for example, 3 circles, right? For this example, so you could do 3 circles here and write down the factors which are common. Perfect. That is what you have to do. Okay, so here is my solution. So as you see, I have taken example in which there are 3 numbers. We need to find greatest common factor between these 3 numbers and also between 2 of them. So 2 of them is simpler, and therefore it will help me to explain you how to make Venn diagram, correct? So we'll begin with these 2 numbers. First step is write all factors. So what are factors of 24? Let's list them. Factors of 24 are, start by writing 1 and 24, right? And then 2 and 12, right? 2 and 12. Common between helps. 3 times 8 is 24 and 4 times 6 is 24, correct? So we get all the factors of 24. Now let me write factors of 30. So 1 times 30 is 30, 2 times 15 is 30, 3 times 10, right? And 5 times 6 is also 30. Perfect. Now, when we compare these 2, we have to circle the ones which are common between these 2. So as you can see, 1 and 1 are common, 2 and 2 are common, 3 and 3 are common, and 6 and 6 are common, correct? So from here, you know, greatest common is 6. But the question is to make a Venn diagram. So let us see how to create a Venn diagram. So in Venn diagram, we make circles. So in a circle, we'll write down all the factors of one number. Let this be the circle for number 24. Now let's take another circle for number 30. So let's say this is my circle for number 30, right? So I'm writing the number outside to avoid any confusion. Correct. Now, to fill in the numbers, we have to begin with common numbers. So here, what will go in? All common factors. So the common factors are, as you can see, 1, 2, 3, and 6. So we have filled in the common factors. Whatever is left will go on the other side. So look at 24 now. So in 24, what numbers are left, which we did not include as common factor? So it is 4, 8, 12, and 24. Okay, so let's list them out. So it is 4, 8, 12, and 24. Similarly, for 30, the numbers left are 5, 10, 15, and 30. So they'll come outside 5, 10, 15, and 30, but inside 30 block. So that gives you Venn diagram. And from the Venn diagram, you can actually write down what is the answer. The answer, of course, is 6. As amongst the common factors, 6 is the greatest. So we can say greatest common factor is 6. Perfect. Now, I hope you have understood how to create Venn diagrams. Now, use this example, just extend and make another circle to fit in factors of these three numbers. Let this be your test question. Pause this video, answer, and then look into my suggestions, okay? Now, let's begin by writing the factors. So we know factors of 24 are 1, 2, 3, 4, 6, 8, 12, and 24. Factors for 30, I'm just copying from here, are 1, 2, 3, 5, 6, 10, 15, and 30. What are factors of 15? It is 1 times 15, right? So let me write 15 here. And then it is 3 times 5, 3 and 5. Perfect. Now let's look for the factors which are common to all three of them. So 1 will obviously be common always. The second number here is 3, which is common. Correct? So let's make our 3 circles. One for the number 24. Correct? The other one will be for number 30. Okay, let's say number 30. And the third one is for our number 15, which is the new number for us. So 15, so that makes this circle. Okay. Correct. So let's write down which circle belongs to which number so that there is no confusion. So this is for number 24. Let me write 24 here. This is for number 24. And then we have number 30. And the last is number 15. So that one is number 15. So begin with the common factors. Where will the common factors go? So this block here is common to all three, correct? All three. So the only numbers which come here are 1 and 3. Perfect. These are 2. Now you have to look individually between, let us say, 24 and 30. So you have to find what is common between 24 and 30, but has not been taken here. Well, we can use this chart. Perfect, right? So we have 1 and 3, 2 and 6 are left. So these 2 and 6 will come here. So we have to fill those numbers. Correct? Now, let us see what is common between 15 and 30. So between 15 and 30, let's mark common things. So now we are looking 2's, 15 and 30. So amongst the numbers left, we have 5 common, and we do have 15 common, correct? So these two are common. So let's write down these two numbers between 15 and 30. They will come here, right? So these are the numbers 5 and 15. With that, we have exhausted all numbers for 15. So the factors of 15 are either common with 24 and 30 or just with 30. It makes sense. 15 times 2 is 30. So of course it has to be like that. Correct? Now, will there be a factor common between 15 and 24 but not with 30? None. So this is kind of empty. Is it okay? Now, we have to worry about the other numbers which we did not include. So in 30, what we did not include? We did not include, well, 2 has been included as a common factor between, so let me circle 2 and 6 also. They have been covered, right, between 24 and 30. So the remaining numbers will go outside in 24 and 30. So in 24, the numbers are 4, 8, 12, 24. So it is 4, 8, 12, 24. Correct? In 30, the numbers are 10 and 30. 10 and 30. So you see how it has changed by introducing 15. These two numbers have gone as a factor of 15, right? So do you see this? These two numbers have been added here as factors of 15. Otherwise, more or less, it kind of same, right? So do you see that? Now from here, we can answer the question, greatest common factor is what? So greatest common factor between all three of them is 3. Is this number 3 here? Does it make sense to you? So I hope with this, we have covered at length all about factors. Correct? So if I have, let me write another question for you, and that is, what is the greatest common factor between two prime numbers? So that is your question to answer. Okay, so think about it, answer the question, and then write down as comments. Feel free to write and share your views. And if you really like and subscribe to my videos, that will be great. Thanks for watching and all the best.